You know, we trust healthcare to fix us, to heal us. But every single procedure, whether it's a simple shot or a major surgery, well, it creates a byproduct. It's this whole other side of medicine that's designed to be completely invisible. And trust me, it's for a very, very good reason.
Because this is what happens when that system breaks down. Every single life-saving act produces waste, and a small but really critical part of it is potentially dangerous. So the big question is, how do we protect everyone else from the very things that just protected a patient? And that's really what this is all about. How do hospitals and clinics and labs manage the millions of tons of waste they produce? How do they make sure the process of healing doesn't end up causing harm? Well, the answer is actually a surprisingly elegant and really colorful system.
Okay, so first things first, we need to get a handle on what we're actually talking about. What even counts as biomedical waste?
The official definition is, well, it's pretty broad. It covers literally everything from a used cotton swab to a discarded organ. And it's generated everywhere from a huge city hospital to your local vet's office. It's the entire stream of stuff left over from the act of providing care.
Now this is where it gets really interesting, because this probably flips what you'd expect on its head. The vast majority of healthcare waste, somewhere between 75 and 90%, is actually no different than your trash at home. We're talking paper, food scraps, packaging. It's that other chunk, that 10 to 25%, that needs our full attention. That's the hazardous stuff.
So how in the world do you manage that risk? How do you make sure a contaminated needle doesn't get tossed in with a paper cup? Well, you do it with a really strict universal code.
And this brilliant system is all based on color. It's like an immediate visual language that every single healthcare worker understands. It takes what could be total chaos and turns it into this finely tuned process of sorting things right at the source.
All right, let's start with yellow. This bin is for what's called anatomical waste. So think human tissues, organs, that kind of thing. It's also for anything that's heavily soiled with blood or body fluids like bandages and dressings. Even expired medicines and certain chemicals go in here.
Next up is the red bin. This is for all the contaminated plastics and rubber. We're talking used gloves, catheters, IV tubes, and even syringes. But just the plastic part, not the needle. And here's the really crucial part. After this stuff gets treated, a lot of it can actually be recycled.
Then we've got blue. This bin is for all the broken or discarded glassware, so things like vials, little glass ampules, and lab slides. It's also the special spot for metallic body implants like old pacemakers or surgical pins that have been removed.
And finally, there's the white bin. Now, this one is arguably the most important for keeping the staff safe. It's a translucent, totally puncture-proof container, and it's designed for one thing and one thing only: sharps. Needles, scalpels, blades, anything that can cut or pierce the skin goes right in here. No exceptions.
So sorting all this waste is the critical first step. But what happens after something gets dropped into the correct bin? Well, its journey is really just beginning.
The whole process follows this super strict chain of command. It all starts with sorting the waste right there, in the patient's room or in the lab. Then it's collected and kept in a secure area, picked up by special licensed vehicles, and then taken for its final treatment and disposal. Every single step is tracked.
And the whole thing runs on a really tight schedule. From the second it's created, hazardous waste generally can't just sit around. It has to be treated within 48 hours. That clock is always ticking to get this stuff safely processed.
This breaks it down perfectly. You can see the final destination for each color. That yellow waste, it's often incinerated at incredibly high temperatures. The red plastics are sterilized with high-pressure steam. It's called an autoclave. And then they're sent off for recycling. Blue glass and metal get disinfected. And the white sharps are sterilized and then shredded into tiny pieces so they can't hurt anyone.
So why go through all this trouble? I mean, why have this meticulous, color-coded, time-sensitive process? It's because honestly, the alternative is just unthinkable.
I mean, just look at the difference here. The contrast is so stark. On one side, you've got absolute chaos, a direct threat to public health, to the environment, and on the other, you have order and safety. The system is basically an invisible shield between the hazards inside a hospital and the community just outside its walls.
And the stakes here could not be higher. If this stuff isn't managed properly, it can release infectious agents and all kinds of toxic gunk. It can pollute the air if it's burned the wrong way, contaminate our land and water, and even allow heavy metals like mercury to get into our food chain. The risks are they're profound.
When you boil it all down, the entire system is built on this one simple but really powerful idea. It's this recognition that the job of caring for someone doesn't end when they walk out the hospital door. It ends when the very last tool has been safely taken care of, making sure that one person's recovery never ever poses a risk to anyone else.
This hidden network of colorful bins and special trucks is just a perfect example of a system working silently, in the background, to keep us all safe. It kind of makes you wonder, doesn't it? What other vital, invisible systems are we all relying on every single day without even knowing they exist,